When you want to start doing projects in cybersecurity, you want to do something that's not really simple, but you don't want to do something that's so incredibly difficult you can't actually achieve it. So I think a natural project to pursue is a network scanner. And that's what this video is going to be about. We're going to write a network scanner using the Bash scripting language. Now, I chose Bash because scripting, I think, is an important skill to build. So this project serves two purposes. One is to learn about cybersecurity by writing a network scanner, and it's also for learning Linux and scripting by using the Bash scripting language. So what is this program all about? What exactly are we writing? Well, it's not going to be simple, but it's not incredibly difficult. So we could just write a script that just takes a single IP address and scans that. To take a really simplistic example, we're not going to write that. Also, we're not going to try to write Nmap either. It's within these bounds of really easy and really, difficult. So what is it going to do? Oh, well, it's going to validate input for one. So we're going to do checks to make sure that the user provides the right input. In this program, you provide the script with 3 octets of an IP address, something, and a range, a lower bound and upper bound. And the program is going to let the user know whether or not this is valid. So it's a little complex in that sense, but not too complex. Also, we're only going to scan a single /24 subnet. We're not going to scan multiple subnets or anything like that, or large subnets. We're just going to do a simple /24 subnet. Simple, not difficult, but more difficult than just scanning, like, say, a single IP address. And also, we're going to provide user-friendly output, such as letting them know what went wrong. Also, letting them know the results of the scan. Is the host up? Is the host down? That sort of thing. You don't just get the results of ping, which is a tool that we use in this script. So what we see here is the script itself, and I'm going to go over all of this. The thing we're going to look at first is input validation. And right here, the first thing we do is make sure that there are exactly 3 arguments in the script. So this construct right here, this returns the number of arguments that were given to the script. So if it's anything other than 3, if it's 2, it fails. If it's 4 or 5, whatever, it fails. So as you can see right here, I was playing around with it, but we just go give it 2 arguments, needs 3 arguments, give it 4 arguments, needs 3 arguments. If you give it 3 arguments, it's going to complain here because it's not getting 3 octets of an IP address, but get the idea. So that's that. So now that we've passed this check, what we do is we take each of those arguments and assign them to a variable. The first argument is supposed to be your IP address. So we assign, this right here stands for the first argument given to the shell script. And we assign that to IP. And then the next argument is supposed to be the start of your range, and the next one is supposed to be the ending of your range. So that sets up the 3 different variables we're going to work with. What we have here is this thing called IFS, which stands for Internal Field Separator. And what we want to do is set the IFS to a period, because that first argument is going to be separated, or we're going to break it apart based on the period instead of it being the space. So after we set the IFS to a period, which it's initially a space, what we're going to do here is this right here looks at the IFS and says, okay, the period is the separator, so every time you see one of those, that counts as a different argument. So we've set our IFS to a period. Right here, we say for arg in IP, which is this, it's that 3 octet thing that we passed at the beginning. We're going to create an array called parts. And this construct right here creates that, or causes that array to be created for us. So parts ends up accumulating each section of IP. So we break apart IP, and once we've done that, we want to verify that there are exactly 3 to it. 192.168, and then, a valid range 1 and 3. It's going to say must be 3 octets long, which is what this checks for. So this construct right here looks at this array, and it should be equal to exactly 3, which is what happens when you give it 3 octets of an IP address. Otherwise, it's going to be greater or less than. So that's what's going on right here. We've broken apart the input. We've broken apart something like 192.168.121 and changed it into 192.168 and 1 whatever. It's basically an array. All right, so we're verifying that it's exactly 3 members big. So once we know that it's 3 members big, the next thing we need to check is that each octet is numeric, because you could pass it something like this: 192.abc.1, 3 and 4. Just use that as the range, and that's not a valid series of octets. And what this does right here is uses regex to check and make sure that each octet is numeric. So remember, parts contains the broken apart IP address. So for every one of those members, like for instance, 192 will be the first member. It's going to look at it, compare it to this, and say, oh, that's numeric. However, it's going to fail when it gets here. So let's hit enter, and it's going to say, oh, each octet must be numeric. So we've checked that we have at least 3 octets. We've checked that each octet is numeric. So the next one here is going to be, we want to verify that the first octet is at least 1, and the second and third octets are at least 0, but less than 256. In other words, a valid, number for that part of the IP address. So what's going to happen here? Verify that the first octet is at least 1, the second and third octets are at least 0, but less than 256. We start with count equals 0 because the first octet, we need to, the others can be 0. The first octet needs to be at least 1 though. So once we check it, we want to check the others in a different way. So this right here, first we set our count variable to 0. And for each one of these, this is what we do. If the count is equal to 0, we're starting with the first octet. So what we want to do here is make sure it's at least 1, which is what this is all about. Arg is greater than or equal to 1, and arg is less than or equal to 255, right? So it'd be valid. And of course it fails if it's not. Now, this right here is a nice little bash construct that lets you use this C-style incrementing for setting count to the next value. So we set count to 1, and that's what it ends up staying as because we don't increment count anymore. But once this happens, then we go to the next loop, or we go to the next step in this loop, and it goes here, and it checks to see if it's at least 0, or it's greater than or equal to 0, or less than or equal to 255. So after all of that, and here, this is also kind of important, even though I don't think I use the IFS anymore in this script. It's just a good practice, I think, to set it back to a space. So what we've done is we have validated, there's probably so much more validation we could do. But this is about this is what I could think of. It makes sure it's a valid octet. Make sure you've got 3 octets, make sure that it's numeric, and make sure that it's valid for an IP address. And I don't really think there's anywhere else you can go other than that. So the next thing we want to do, once we've validated that the first 3 octets are part of a valid IP address, we just want to do 2 things with the range. One, we want to make sure that the end of the range is greater than the beginning of the range. And we want to make sure that both of them are greater than or equal to 0 and less than 255, or less than and equal to 255. So this conditional statement right here just makes sure that the start is not greater than the stop. And what we've got here, this conditional statement, well, this should actually be 255. So the start of your range, if it's 255, it would fail, which, you know, if you wanted to just scan 255, you know, something .255, you just put 255 for the start, 255 for the stop, but we won't worry about that. But anyway, this makes sure that the start of your range is between these bounds, and that the end of your range is between these bounds. So this validates our range. So we've validated all of the input, which is pretty awesome. And we give the user friendly, we give the person user-friendly feedback, which is nice too. So now we come to the scanning part. And that code is this little snippet right here. So what does this do? Well, what we're going to do right here is set current to start. So it looks something like this, right? Let's say current, your start value is 3, right? Okay, so current set to 3. What we do is while current is less than or equal to the end of the range, the stop, we're going to do this. And here's what happens. What we do is we use this construct right here, which gives us the output of the ping command. It's going to store whatever ping gives us to this variable output right here. In this line right here, what we do is we look at this right here, and it's really interesting. This was my favorite part of this script because it was just a fun problem-solving exercise. See, what happens here is whenever we send the command, whenever we send the output of a command, right here, what I'm going to do is demonstrate what happens when you send the output of ping to a variable. We're going to do ping 4 times, just 192.168.1.1. All right, and it's going to take all of the output from ping and send it to this variable called output. And if we echo output, you'll see here all of this stuff. It's a big scrunched mess, but what's important, if there's 100% packet loss, we know the host is not up. Now, this is where the simplistic, the not too complicated part comes in, because, the packet loss could happen several times before you finally get the host up. I mean, I imagine. But I'm like, okay, we'll just ping it 4 times, and if it doesn't respond after 4 times, then it's down. If it responds at least once in 4, then it's up. So what this does right here is it uses regex to look for this string right here, 100% packet loss, in all of this output right here, which goes on behind the scenes. And it's nice and user-friendly because the user doesn't have to see this. All they have to see is this right here. IP is up, or IP is not up, or the IP is up. And of course, we have that nice C construct where we can just increment current to go to the next IP address, and it does that until we're done with our host. So here we go. Let's give this program a whirl. We're just going to scan a few hosts. It's incredibly slow too, because of course it's waiting for the output of ping, but of course it was not my intent to create like a robust or efficient network scanner. It was just my intention to learn about scripting and get acquainted with things like network scanning and just think about stuff like that. So let's give this a shot here. We're just going to scan the local network 192.168.1, and our start range will be, let's just say 1, and our ending range will be 4. So now it's going to go very slowly, but it's going to tell us if a host is up or if it's down based on whether or not it saw that 100% packet loss string in output. So yeah, 192.168.1.2 is not up, and we're most likely going to find out that 3 and 4 aren't up either. And yeah, it's going dun, 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 Anyway, we'll stop it here because that kind of demonstrates it. So that's the network scanner, and through all this we learned a little bit about bash scripting, learned a little bit about network scanning, methods of, prettyifying our output to make it a lot easier to read and whatnot. And we learned how to scan a range of hosts. Nothing complicated. There was looping covered. There were different bash constructs covered. So there's that stuff about the IFS. If you want to break apart an IP address and put it in an array, that's covered. But anyway, very simple program. Very fun first cybersecurity project. And, that's pretty much all there is to it. So see you, pals.